Okay, so today the plan is to get 13A, 13B done and maybe moving into 13C. We'll see how we're going. But I just want to start off here, so we're not wasting time me writing all the stuff up on the board. I'm just going to start here with this, and this will be enough to get you through question 1 and 2. And I'd like us to do that in sort of 5 minutes, and then we'll move on to the next part. So we'll do it sort of in baby steps, just so that we can move through it reasonably quickly. Okay, so I'm just going to show you the process and then explain what logarithms are in the next step. Okay, so log 1,000, what we need to do is we need to express this number as a single power of 10. Okay, so powers of 10, 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1,000. So that means we're going to write this as log of 10 to the power of 3. And because we've expressed it as a power of 10, a single power of 10, it simplifies to the integer that is the power. Okay? Log 1 on 10 we can express as log of 10 to the minus 1. Okay, we've expressed it as a single power of 10, and so it simplifies to the integer minus 1. Okay, cubed root of 100. So we need to express it as a single power of 10. So there's going to be a number of steps here. The first is that 100 is 10 squared. Okay, so that's the first. The second step is that cubed root of any number, cubed root of a, is a to the third. So we've got the cubed root of 100, well that's 100 to the power of a third. Okay, so that will simplify to log to the power, 10 to the power of 2 on 3. Because the 2 multiplies the third, 2 times the third is 2/3. And then that's going to simplify to the power there, 2 on 3. We've expressed that as a single power of 10. Okay. In D, we've got log 1,000 on log root 10, log 1,000 on root 10. So we're going to express that as log of 10 to the 3 on top of 10 to the half. Okay, we've expressed both as powers of 10. Now they have the same base, so we're going to bring them together. So the next step, we have log 10 to the 3 take a half, which is log 10 to the 2 1/2, 5 on 2. And we've expressed it as a single power of 10, so it simplifies to the power. Okay, so index all there, top power take the bottom power, 3 take a half, 2.5, 5 on 2. Okay, last one. The top power is already expressed as a power of 10. The bottom power we need to change. So we're going to have 10 to the A on top of 10 to the power of 2 to the power of B. 100 is 10 to the power of 2. And that B will distribute. So baby steps here, we'll have 10 to the A on 10 to the power of 2B. We have the same base. So the top power take away the bottom power. Go sideways rather than down. And so that's we've expressed it as a single power of 10, and so it simplifies to A take B. Excellent. So that's enough to get in. Have a go at question 1 and 2 of 13A. Let's spend about five minutes doing that. Okay, so we're back up here. I just want to talk about what they mean. So this is the graph of 10 to the power of x. Okay, so right here, you've got 10 to the power of 0 is 1. Any number to the power of 0 is 1. Here when we have 1, 10 to the power of 1 is 10. 10 to the power of 2 is 100. Okay, and so you could work out, well, what's 10 to the power of 1.5? And you could get that from the graph here, okay, around about 50 or something like that. So then what we're asked to do, it says, what does, let's do it in terms of what we have here. What does log 50 mean? We'll do that one in a moment. What does log 100 mean? These are the questions that we're addressing in logarithms. Now we know log 100, okay, that's going to be log of 10 to the power of 2, that's going to be 2. Here's what it means, okay? 10 to the power of 2 equals 100. Okay, so when we say log of 50, and I've simplified that one here in our book fortunately, I've got 1.69, 897, it keeps going, 897. Okay, so if you put this in your calculator, this is what it's going to smash out. It means 10 to the power of 1.69897 equals 50. Okay, that's what it means when you evaluate log 50. Here I've got written down as well, log 200. We can't see that from our graph, okay? It's going to be up here somewhere, isn't it? When y is 200. It means 10 to the power of what equals 200, okay? If we put log 200 in our calculator, we've got 2.301. Okay, so therefore, 10 to the power of 2.301 equals 200. So when you calculate the log of a number, it's determining 10 to the power of what is going to give you that number. Okay? So log of 50 means 10 to the power of what equals 50? Well, 10 to the power of 1.69897. Okay? Log 100 means 10 to the power of what equals 100? Well, 2. 10 to the power of 2 is 100. Okay, so that's what they mean. Use your calculator to figure these out. So let's pull our calculator out. I'll show you where the log button is, because you're going to need that. So the log button is right below the x squared button, sort of in the middle, just to the left a bit. There it says log. All right. So we're going to press log 22 equals 1.3424. I think it says in 4 decimal places or something, does it? Or it doesn't specify in this question? It doesn't specify. So we'll just go to 3 significant figures. 1.34. State the significance. Well, what it means is 10 to the power of 1.34 is 22. Okay, that's the significance of our result. Okay, log 694, let's calculate that. Log 694, we've got 2.841, which is 2.84. What's the significance of it? Well, log of 694 means 10 to the power of 2.84 equals 694. And then same again, log of 3421. We've got 3.534, which is still 3.53. What does it mean? What does this number mean? It means 10 to the power of 3.53 equals 3,400. Okay, so it's gotten us to calculate that there for us. In question 4, write in the form 10 to the power of x. Write in the form 10 to the power of x. Well, when it asks us to do this, we know that log of 15 is going to tell us the power that we need to raise 10 to in order to get 15. So let's calculate log 15. I've got 1.176, so that would be 1.18. Therefore, 10 to the power of 1.18 equals 15. Okay, same with 2,431. All right, we're just going to log it. What's the logarithm of 2,431? I've got 3.385. All right, which is 3.39. So therefore, 10 to the power of 3.39 equals 2,431. See how we've written it in the form 10 to the power of x? This is the 10 to the power of x form, 10 to the power of 1.18, 10 to the power of 3.39. Okay? Last one. Okay, so here over here we've sort of been manipulating logarithms. We're saying what do they mean? What are their values? Over here we're going to solve some logarithmic equations. Now for 13a, for now, all we need to do to get rid of the log is put 10 to the power of both sides. Okay, so remember these sides of the equation are equal, so you can do anything you want as long as you do it to both sides. So here's what I'm doing to this side, 10 to the log x, and here's what I'm doing to this side, 10 to the 0.351. Now, this is the rule, 10 to the log x equals x. Okay, so we've moved from there to there to there. And then over here, 10 to the 0.351, well, we can just put that in our calculator. 10 to the 0.351 I've got 2.24. Okay, same with b, put 10 to the power of both sides. This simplifies to x, and then 10 to the power of 2.3 is 199.5. So we'll round that, three significant figures, that would be 200. And last one. Okay, so let's look at the difference between here and here, and let's just talk about that. So here we're saying log of what number equals 0.4, and then over here we're saying 10 to the power of what equals this number. Okay, so that's the relationship there. Log of what number equals 0.4, okay? What does it mean? It means 10 to the power of 0.4 equals what? 10 to the power of 0.4 is going to be this number here. And then over here, 10 to the power of what is going to equal 22. So log of 22 is 1.3. 10 to the power of 1.34. So they're linked, you can see that. Okay, let's get into the rest of the exercise.